Assalamualaikum warahmatullahi wabarakatuh. My name is Luqmanul Hakim bin Muhammad Kamis. So today I will present about the application of ohmic heating in food industry. So content is the introduction, principle of ohmic heating, electrode arrangement, advantage and disadvantage of the ohmic heating, application of ohmic heating, conclusion and also reference. So first for the introduction. Ohmic heating is an emerging thermal process technology and describes the process when an electrical current is passed directly through a food and the resistance imposed by the food leads to the generation of heat within the product. So the basic principle as well as the main factor including influencing ohmic cooking have been explained by Sastry et al. 1992 report that ohmic heating can be used in a continuous flow mode to cook and sterilize liquid food and solid liquid mixture. The ohmic heating, which is known as the electrode heating technique, is in use for commercial scale operation for the processing of a number of food products. It is based on a passing electric current through an electrically resistant food product. The ohmic heating is an advanced thermal processing method in which heat is internally generated within food by passing an alternating electric current through them. Ohmic heating can volumetrically heat the entire mass of a food system, resulting in faster heating, better quality, and less energy consumption than conventional thermal processing. So here are the difference between ohmic heating and also conventional heating, which is the ohmic heating use rapid heating, low maintenance, fast cooking, more healthy due to the not use of the oil. While for the conventional heating or others cooking method, it use the direct flame heat air to cook the product and also high maintenance, slower cooking, less healthy due to the use of oil. So here are the principle of ohmic heating, which is the main part of ohmic heating is the power supply, heater assembly, control panel. So an ohmic heater, also known as a Joule heater, is an electrical heating device that uses a liquid electrical resistance to generate the heat. Heat is produced directly with the fluid itself by Joule heating as alternating electric current is passed through a conductive material of resistance, which the result energy generation causing temperature rise. So the most commonly used heating technique for liquids rely on heat transfer from a hot surface. This heat can be generated directly via an electrical heating element or indirectly from a hot medium. Example given is a steam. So this method requires temperature gradient to transfer heat to the processed liquid, and as such the surface are at high temperature than the product. So ohmic heating work in principle of Ohm law of electricity, where V is equal to voltage, volt, I times R, which is I is the current, R is the resistance. So here are some video of the how the process of the ohmic heating. So here are the control panel of the ohmic heating, and here are the timer, and the green one is the push start button, and here is the main switch, and this is the plate of the ohmic heating where we put our food product, and then we close the plate, and then we push the start button and let the food cook itself. So this is the ohmic heating, which is the advanced thermal processing method, which heat is internally generated within food by passing the alternating electric current through them. Ohmic heating So you can see that the smoke is coming out from the plate, and after a few seconds the beef patty is fully cooked. It just takes much faster than the other method of cooking for beef patty. So this experiment is conducted at UiTM Shah Alam. So it shows that the omit heating is much more faster than others heating treatment. So next is the design parameter. The main parameter of omit heating concerning the variable inherent of the process, equipment and product, which is the parameter is the processing parameter, which is the factor is the electric field strength, time, temperature, frequency of electric current. Next is the product parameter, which is the factor is the electrical conductivity, viscosity, density, specific heat, homogeneous or solid liquid system. Next is the equipment parameter, which is the factor is the size of ohmic cell, size and shape of electrode, and also electrode composition. So here are the electrode arrangement. So as we can see is that A is for parallel plate. This one is more suitable for low conductivity fluid and also offers a benefit where there are large solid particles with minimal shear force. Due to the completely unrestricted flow channels, the electric field uniformity is optimized in this geometry, improving even heating. The design can usually operate at standard voltage. For example, given 240 volt or 415 volt. And it is shown in figure A. So next is the parallel rod design, which is normally utilized where contemplation costs are principal. For example, squander slurries. The structure is considerably less costly to build than the parallel plates or collinear plates, yet gives less in heating. Thus, the fluid regularly should be made subsequent to warming to try and out of the temperature. So next is the collinear design, which is for most applications, this design requires a higher voltage than the parallel plate. So the electrodes can be positioned in the fluid stream or as collar around a pipe which provides a fully unrestricted flow channel. It is a better option for high conductivity, offering wider electrode spacing. As so the current distribution is less even and areas high current density found at the leading edge of the electrodes can produce localized boiling and arcing. And lastly is the staggered rod arrangement. An alternative minimal cost, however, can give more in heating than the parallel rod design as appeared in figure 2D. So here are the advantage and disadvantage of the ohmic heating. There are advantages and disadvantages should be considered depending on the purpose of the objective. For considering heating applications, since ohmic heating use electrical energy, a comparison of ohmic heating with other heating method, such as heat pump heating or microwave heating, was concluded. It is clear that ohmic heating method is one of the efficient way in heating application. So as we can see, the advantage of the ohmic heating is instant on off of the system, like we just saw in the video just now, and it is low cost maintenance, very clean and hygienic due to and also minimal thermal deterioration of food resulting in minimal mechanical damage, low risk product damage due to the low risk product damage of burning. The disadvantage of the ohmic heating is difficult to monitor and control, lack generalized information, low conductivity food cannot be processed, expensive in term installation and equipment manufacturer, rapid increase of conductivity with temperature may lead to runaway heating. So next, the application of ohmic heating, which is and poultry processing, fruits and vegetable processing, and also water distillation processing. For meat and poultry processing, the application is the heating and thawing. For the sausage product, the condition of the meat heating is 230 volt, 50 Hz, 3.5 to 7 volt per cm, which the effect is the higher salt content required, higher fat content reduce the electrical conductivity compared to the steam cooking. And next is for the beef product, up to 250 volt, 50 Hz, 50 ampere, and 9 cm electrode spacing, which resulting in brighter surface color, no significant change in the texture. While for the turkey meat, it used 8.23 volt per cm, 100 volt, that at A, low temperature long time, 72 degrees Celsius for minute, 80 degrees Celsius 3 minutes, while for B, high temperature short time, STST, 95 degrees Celsius 5 minutes. The heating was faster than which the conventional heating, higher quality which LTLT, but better flavor development which high temperature short time. So next for the fruits and vegetable processing, the application used was the pasteurization, which is the product is fish and pear. It used 13 volt per cm, 15 per 60 Hz, 100 volt, combined with vacuum impregnation for conditional preservation, which is the effect it always used after vacuum impregnation, permeability of the cell increase. For the pomegranate juice, the condition of heating is 30 to 55 volt per cm, 60 Hz, 20 to 85 degrees Celsius, which is the ohmic heating rate, and the pH value decrease as the voltage gradient increase. The electrical conductivity increase as the temperature increase. So for Acerola, 120 to 200 volt, electrode spacing not specified. It will decomposition of vitamin C during ohmic heating treatment, which a low voltage gradient comparable to conventional heating, indication of electrochemical reaction. For next is the grape juice, 20, 30 and 40 volt per cm, 60 to 90 degrees Celsius, which is the effect is the optimization of polyphenol oxidase inactivation. Next for the blueberry pulp, up to 240 volt, electrode spacing not specified, is up to 90 degrees Celsius used. Decomposition of anthocyanin during ohmic heating treatment, which a low voltage gradient was the same as or lower than during conventional heating, which is increased at higher voltage gradient, and was also higher with an increasing content of solid material during ohmic heating treatment. For apricot, which is 20 to 70 volt per cm, 50 Hz and 70 degrees Celsius. The electrical conductivity was dependent on the temperature, ion concentration and pulp percentage. So last is the water distillation processing, which is the application used is heating and thawing. For water, the 500 ml using both electrode conversion at 11 volt per cm. So the results show a significant decrease in the values of calcium, and potassium for all water sample treated using the ohmic distiller when compared to the untreated sample. So the conclusion, the ohmic heating is especially advantageous in processing semi-solid or particulate food. It has proven advantages over conventional thermal processing and novel thermal alternative technology like microwave heating, radio frequency heating, and induction heating. So it is will better product quality, less cooking time, lower capital cost, better energy efficiency, and an environmental friendly process are the key advantages of ohmic heating. It requires lower capital cost compared to the electro heating method. So the application of ohmic heating for meat and poultry and water distillation process are heating and thawing, while for vegetable and fruits are pasteurization. So the recommendation, it is recommended to do further research study rate ohmic heating by carrying out the research about microbial growth after treatment with ohmic heating. So here are the reference, and that's all. Thank you from me.